Hey Spring fans! In this installment of Spring Tips, we're going to look at how to build robust services that do the right thing even in the face of downstream service outages or failures. So let's go ahead and build a simple application. We're going to do this using Spring Boot and some components from Spring Cloud. Let's build an application called the Robust Client. We're going to use Spring's web support, naturally. We use Actuator. We're going to use the Spring Retry library. And we're going to use the Netflix Hystrix circuit breaker. Okay, now we'll hit generate. But I don't want to just use the version of Spring Retry that we have on the class path. So I'm going to go ahead and instead add a preliminary version of Spring Retry to our build. This version is 1.2.rc1. This version hasn't been released yet. It's that version itself is released, but it's not GA. So we want to take advantage of that GA non-GA code by going to our build and changing the dependencies, adding the snapshot repositories, the milestone repositories to our build. And we want to promote, by redefining a property, we want to promote or bump up the version of Spring Retry itself here to 1.2.0.rc1. And with that, we can build an application. So let's go ahead and set the stage, okay? Let's build an application called the Shaky business service, okay? And this may potentially call some other web service, right? It'll call something else and do something interesting. So we're going to derive some sort of number, and we're not going to actually bother calling another service because we can just fake it, right? We can just say if math.random greater than 0.5, then we'll throw an exception. We'll throw a new runtime exception. Signaling that something is wrong, and when that happens, we'll also sleep. So we'll simulate a timeout, if you will. When we call a downstream service, we'll sleep for 3 seconds, and we'll add the exception accordingly. Otherwise, we'll just return 1. So if everything goes fine, we'll return 1. Otherwise, we'll call this downstream service, this fictitious service, and something will go wrong. And we want to be able to exercise this potentially shaky service by creating a REST controller. So I'll say shaky REST controller. And our REST controller will take advantage of the newly created shaky business service. So we'll inject that there. Create the constructor at AutoWire here. We'll say this.shaky business service equals shaky business service. And we're going to create an endpoint that's going to be exposed as public int boom. And all we're going to do is we're going to return the derived number if possible. And we'll deal with the exception. So what will happen is if there is an exception, right now that exception will get bubbled up to Spring MVC, which will then report a HTTP status code 500 in response. So let's go ahead and try it out. Let's go ahead and see what we get just for this, okay? We'll see it spin up on port 8080/boom. There it is. Okay, it threw an exception, it timed out, and it bubbled up to the Spring MVC handler layer, and we got the status code 500. That signals that the server had a processing error. This is a generic error, and our client isn't going to know what to do with this, right? It's better not to put that client in a position in the first place. Instead, we should handle it if we can, and then potentially degrade gracefully. We want to make sure that if there is something wrong, that we do something better than just propagating a big fat Java stack trace, or even more cryptically an HTTP status code like this to the client, or a potential iPhone client, or an HTML5 JavaScript client, for example. They're not going to have any idea what to do with this. So instead, let's introduce a fallback mechanism. There's a few ways to do this. One way, of course, and I assume a lot of you already know about this, is we can use the Netflix Hystrix circuit breaker library, and I have that on the class path here. This is Spring Cloud Starter Hystrix, and in order to activate it, I just need to I need to activate the circuit breaker there. I need to say @enable circuit breaker, and then I annotate my potentially shaky business logic here. I annotate it with @hystrix command. Now this is actually a annotation from a third-party library called Javanica, and Javanica adapts the underlying circuit breaker library to the Spring component model and provides this nice annotation. I'm not really a big fan of having to call or tell it what to call using a string, right? This is kind of ugly, but Hystrix itself has a lot of benefits, right? So what we're saying here is we want to call this fallback method. It has the same signature except for the name, of course. It has the same signature, and we're saying that we want to call that method and then return just 2 instead of 1. So a lot of high-performing websites will do this kind of thing. They'll say, oh well, you went to the search engine service, and that's not available right now. So instead, here are some machine-learned recommendations from across the web. Is it what you wanted? No, not quite, but it's better than nothing, right? Certainly. So that gives us some benefits. Now, behind the scenes, what's actually happening is Hystrix is creating what's called a command object, which is basically a context. It's like a runnable, but it's a runnable that's managed within this circuit breaker sort of context. And the circuit breaker provides isolation in one of 2 different ways. What we want is to make sure that if this method goes off the rails, if it throws an exception, that we don't run the risk of permanently blocking, for example, or permanently losing our control of that thread. So one way you can isolate potentially shaky service-to-service calls is to use an isolation mode called thread, right? And this is a configurable setting in the Hystrix circuit breaker that ends up creating a whole new thread every time you call a method that uses the circuit breaker. So it wraps this method invocation inside the body of a thread. And that means that if you've got any kind of components that are using or relying upon thread locals, and there are a lot of them in your average application, be it Spring or not, right? If you're trying to do managed transactions, if you're trying to do tracing, if you're trying to do Spring security, I mean, there's all sorts of places where this gets hairy. Then you need to know about that, right? That becomes a sort of a thing that's underneath your code that you may not know about that now can go wrong, and it can go wrong in very silent, mysterious ways. The other way to isolate things is to use semaphores. This limits the number of threads that may be called. It limits the number of invocations that may be called by limiting the invocations to the semaphore, whereas with a thread option, you limit the number of invocations that may be called by limiting the number of threads in the pool. There are trade-offs. The semaphore approach is obviously much cheaper in terms of resource contingent and so on. It's not going to create a new thread for every downstream service. On the other hand, if you have something that may block forever, at the circuit breaker level, there's no way to regain that. There's no way for the circuit breaker to garbage collect or reap that lost thread, right? That may just go on forever. Whereas if you are using the thread isolation, that thread is managed by a thread executor, a task executor, something like that, right? A thread pool, and you can manage that more explicitly. You can destroy that sort of sideline process. So the choices are, there's tension there. There are various things you can do to tune and finesse your performance characteristics. So okay, good. Let's see what this looks like. We've introduced the circuit breaker. We'll restart it. Now, I said they have to be the same signature. Suppose I had a path variable, a Spring MVC path variable here, right? For example, path variable, and I wanted to match a certain parameter in the path. I would have to declare the string type there as well, right? Even though this isn't Spring MVC, I have to have the same identical parameters there. So keep that in mind. Okay, so localhost 8080, boom, 1. Okay, fine. Now it looks like it's going to hesitate. There's 2. So what happened was the exception. We got the shaky scoped block. It hesitated for a second, threw an exception, and we get the circuit breaker. So okay, hesitation. Let's see if we can call enough of these services here. There you go. Now you see when I call number 2, when I call the endpoint now, it's going directly to 2 and it's not hesitating anymore. So 1 is what we get if everything's happy. 2 is what we get if there's an exception, right? That's the fallback method. But in the very beginning, when we call the fallback method, it would hesitate at first. And eventually, we got enough fallback methods that we'd see this stop hesitating. Now it's going directly to number 2. Well, it was a second ago. There. Let's see if we can... Yeah, now it's not even hesitating. It's just going directly to number 2. What's happened is that the circuit breaker is no mere try-catch block. It's not just a fancy way of doing a try-catch block. It's stateful. It monitors the pathway sort of between the client and the downstream service it monitors the logic inside that circuit breaker. And if it sees enough successive attempts have failed, it'll sort of switch the train tracks, directing traffic to the fallback directly. This gives our downstream service time to recover. So if you're calling a downstream service and that service isn't responding, the last thing you should be doing is to continue deluging it with requests while it's trying to recover. So this gives that downstream service time to breathe, gives it time to recover. If you've got something like Cloud Foundry will move heaven and earth all day and all night to restart that service, and it'll eventually come back online. When it does come back online, we want to reintroduce traffic, and so the circuit breaker has a reset timeout. It is going to attempt to reintroduce traffic if possible. So here you can see it timed out. I got the circuit breaker, but even if I trip the circuit breaker, even if I open it, eventually it'll reintroduce traffic, and I was able to go back to 1. So it's not permanently set into that sort of switched track mode. It can go back into the main pathway as we'd expect. Now, this is all very useful, but I think one of the most interesting things about Hystrix isn't so much this behavior, it's the fact that you can monitor it, you can observe it using the Hystrix dashboard. You see, every circuit breaker provides a service end event heartbeat stream if you register the Spring Boot actuator in your class path, if you have that on the class path. So here is Hystrix.stream. It's an actuator management endpoint. This stream contains information about the circuit breaker, the state of the circuit breaker. And you can use that for your own purposes, or you can plug it into something called the Hystrix dashboard. So let's do that. Let's create a Hystrix dashboard here. And we'll use Spring's web support. We'll use Hystrix dashboard itself, and we'll hit generate. Open this up. And we're going to run this application on a different port, right? We want to run this on a different port because we've already got something running on port 8080, right? That's our app. So we'll say 8010, and we'll configure the Hystrix dashboard there, and then that'll do. So let's spin that up. That'll spin up in port 8010, and what it's going to expect as its input is this this service end event heartbeat stream. So localhost 8010 hystrix.html. There we are. Paste it in there, hit monitor, and now you can see that as I make requests on the left, the moving average on the right is going up. It's showing red where it says 40%, 43%. Those are the number of requests that are getting through and that have errors, right? So 42% of the requests are failing. That's roughly what we expect, right? We said if it's roughly greater than half, it'll trip the exception. Eventually, we get enough successive attempts, and you can see the circuit is now open, right? So we can see that reflected here. Something is wrong. Remember, we can't change other people's services. We cannot add our instrumentation and monitoring to their systems. All we can do is monitor the sort of ingress and egress points in our application, and monitor the flow of traffic from our node to their nodes through the circuit breaker. And that circuit breaker dashboard, in effect, stands as a sort of monitoring for their service. If the circuit breaker is open, then we know that their service is down, right? This is very useful because now we have that sort of bird's eye view, at a glance sort of visibility. Naturally, I've only got one circuit breaker and one service instance and one service at the moment, but if I had more than one, I would want to multiplex all of those circuit breakers into one screen. And for this, I could use Spring Cloud Turbine, which allows me to take all of the circuit breakers from all the different nodes in the system and sort of aggregate them into one stream, which I could then plug into this dashboard, and I would have dozens or hundreds or thousands or however many widgets all on one page for at-a-glance sort of comprehension. All right, so this is certainly one way to achieve what we're trying to do, which is to introduce a little bit more robustness in the code to make sure that if something goes wrong in the downstream service, we can do the right thing, right? But what I really want to talk to you about today is Spring Retry, right? So Spring Retry is a different approach. Spring Retry is a library that was originally developed inside of Spring Batch, and Spring Retry has been extracted out from Spring Batch as a separate library, and it's used by lots of different other projects. So Spring Batch, of course, Spring Cloud Dataflow, which uses Spring Batch, Spring Integration, and several other projects in the Spring ecosystem use Spring Retry. So it's one of our most popular and most popularly downloaded libraries, even if it's not necessarily a top-level project. Although, if you're asking me, I think it really should be, right? It's a very, very useful library in of itself. One of the new features, one of the nice features in Spring Retry 1.2.0 RC1 and beyond, soon to be GA, is support for a circuit breaker. So let's look at the circuit breaker. Let's look at Spring Retry without the circuit breaker first of all, and then we'll look at how to turn on the circuit breaker functionality. So here's our fallback method, and here's our potentially shaky service-to-service call. We're going to go ahead and enable Spring Retry, so we'll say @enable retry, and my expectation, of course, is that most people are going to consume this stuff from Spring Boot, so this is all you need. And then we have here the same kind of thing. We have a retryable, right? And here we're going to say that we want to include a certain exception, right? If we don't include anything, then all exceptions will trigger a retry. And here we have @recover, right? And what we're expected to pass here is is the type of exception we want to handle. So I could just leave it as is and decide to handle runtime exception, right? EX, and I could log the exception there. So this gets paired; they get matched, right? If this method throws an exception, then this method gets invoked as sort of the recovery handler. Now let's create a custom exception just to be very specific to demonstrate some of the configuration. So we'll say boom exception extends runtime exception, and we're going to override the constructor here, passing in a string, and it will say that we want to include boom exception. So that's going to be just this exception. All the other exceptions will trigger a 500 status code. It'll bubble up to the Spring MVC layer, and we'll see that reflected. So boom exception, and over here we have a generic we have our generic fall through method, and we can leave it as runtime exception, or we can be very specific and sort of handle only this particular type of exception, and we can have multiple recover methods in the same component, right? It doesn't really matter. Now, just as with the circuit breaker, with a Hystrix circuit breaker rather, the signature has to match. So we have this, we have both of these as we did before. Let's go ahead and restart this. Now this is just retryability, right? This is not as smart as a circuit breaker. It doesn't keep enough state to then permanently sort of route the train tracks to the downstream service. It'll always attempt to call the service, and then if it fails, it'll retry. So let's see what that looks like. Here we go, exception. It's failing. It's trying multiple times to call that service, and we're waiting for the response to eventually come through. So if it's not able to get the result enough times, we'll see that it'll eventually call the fallback. So let's use a logger here. Actually, I can just print out calling derive number. Okay, we'll add that to the output there. We'll restart. So now as it calls the method, we should see it being retried multiple times. This is ideal for things that are idempotent, like reads. Right, so calling derive number. See, I'm not invoking it; it's just printing out in the console, and eventually it gives up. Right, eventually it either gets the successful result, or it times out and we get the fallback method. So there we are. Everything seems to be fine. Now it's doing it again. I haven't touched the keyboard. It's just invoking it 3 times in succession, or several times in succession for us. So this is the standard behavior of Spring Retry. Spring Retry does not have the ability to isolate things based on semaphores or threads yet, but I would argue that's actually not really a problem, because we can use @async, for example, right? You can use @async. This is an annotation that's been in Spring since Spring 3.1, and basically when you add this to a method, it invokes the method inside of a thread pool. So you can say @enable @async, specify a task executor, and then this just works. And now you have more explicit control, and you can see that there's going to be some sort of thread logic in your code that, it's very much a surface level concern now. You're aware of it. The other thing is that we haven't really enjoyed the same sort of circuit breaker like functionality, right? So we actually need to. We're gonna go ahead and take advantage now of a new feature in Spring Retry called the circuit breaker, and I expect that this circuit breaker annotation will be sort of integrated with the @enable circuit breaker annotation inside of Spring Cloud eventually. So that way you can choose to use either Hystrix or to use Spring Retry, and they'll both be activated by using @enable circuit breaker, just like we did with Hystrix. But in our case, the only thing that we need to change is circuit breaker itself, and everything else is very, very much the same. We have different parameters here. The reset timeout is it's basically 20,000 milliseconds. So that means it's going to wait 20 seconds before it attempts to reintroduce traffic, right? So we'll say, we'll just leave it as is actually, that's fine. So let's go ahead and hit the circuit breaker. This circuit breaker provides everything that we need except for that service end event heartbeat stream, right? So I like this, and I think it's a much cleaner model to design recover methods in terms of exception types than to design it using these sort of stringly typed annotations specifications. So here we go. It's calling the downstream service, hesitating, stuttering, calling, stuttering. There we go. Now you can see it's calling the downstream service. It's going directly to number 2. It's going directly to the fallback because it's a circuit breaker now, right? It's doing the same kind of thing as our Hystrix circuit breaker is doing. So this is a very, very convenient. In practical terms, they are functionally equivalent, I think, except for the service end event heartbeat stream. I have it on good authority that building that circuit breaker, service end event heartbeat stream in a way that would be compatible with the Hystrix dashboard shouldn't be too hard. So maybe we'll see that make an appearance before GA. Who knows? Either way, I encourage you to go out and grab the bits, kick the tires, and have fun building services that do the right thing in the face of service outages and failures.